Hello and welcome to my little IR Sandbox. I'm Michael Wylie, the Director of Cybersecurity Services at Ritchie May Technology Solutions. Prior to joining the firm in 2018, I ran my boutique cybersecurity consulting firm in Los Angeles, California. We help clients with offensive and defensive security engagements. We help build security architecture and design, and got our clients through governance, risk, and compliance. I have also built some of the training programs for local colleges and the California State University system. I took some of that experience and built out cyber ranges and training courses at local military bases. Let me tell you a little bit about Ritchie May Technology Solutions. The firm has been around for nearly 35 years, acting as a trusted advisor to many organizations. The firm as a whole offers many different services. However, I am part of the technology service team that offers cybersecurity consulting, cloud services, managed technology, governance, risk compliance, and content protection for our friends in the entertainment industry. So why might you need a IR Sandbox? Well, let's look at a couple statistics before we get started. Verizon DBIR report says that 92.4% of malware is delivered via email. And on the right-hand side, you can actually look at that graph and see that a majority of malware delivered over email is either in a Microsoft Office document or an archive such as a zip file. Sophos reports that 75% of businesses hit by ransomware were already running endpoint protection, yet they still got ransomware. So we've got a problem there. Also, Sophos reports that an average cost per ransomware incident in 2017 was $133,000. That's a lot of money. There's a lot of different reports out there stating different statistics around malware and ransomware. So let me summarize a couple of them that I thought were interesting. McAfee Labs threat report indicates that in Q1 of 2019, ransomware attacks grew by an astonishing 118%. That same report indicates also that there was a 29% increase in cryptojacking campaigns. If we take a look at TrustWave Global Security Report, they state that there was a 1,250% increase in coin miners that they saw within malware. The IBM cost of a data breach report indicated the average total cost of a data breach in 2016 was only, well, you might say only, but it's still a lot of money, $3.54 million. Whereas it grew to $8.19 million in 2019. Significant increases. And Symantec Internet Security Threat Report indicates that 1 in 10 URLs are now malicious. And if we look at the graph on the far right side of the screen, we can see that business detection between 2017 and 2008 saw an increase in Trojans, hijackers, riskware, backdoors, and even spyware. There's also case studies out there. So if the statistics aren't enough, let's look at some of the big cases out there. NotPetya paralyzed a large shipping organization. You've probably seen their logo before in 2017, causing $10 billion. That's B with a billion. Billion dollars, not million. That's a lot of money. It was part of a Russian zero-day malware, and once infected, systems then started spreading the malware over PSExec and WMIC using the lull bins. Email wasn't functional, people were reverting back to paper reports, the shipping was basically put to a halt. The company lost tons of money, their customers were upset, it was a big fiasco. Another case study, let's take a look at the city of Atlanta. They were infected with SamSam ransomware. The cyber criminals asked for a mere $51,000 in Bitcoin. The city decided not to pay that and ultimately ended up spending, their first report said, $2.7 million to recover from the ransomware. But later on, they reported higher numbers, like $16, $17 million in that recovery. The ransomware incident was attributed back to 2 Iranian hackers, which were indicted. The ransomware reverted the city back to paper reportings, doing all kinds of police reports over paper. Their computer systems were halted. They lost decades of work, according to some reports. If you want more information on this, go ahead and search on YouTube, B-Sides Augusta 2018, Michael Wylie, The Costly Mistakes of Being Unprepared, and I talk a bit more about this incident. So what can an IR Sandbox do for you? Well, it can be a safe place to detonate malware, to poke around, see what the malware does, or a file that you don't know if it's malware or a legitimate piece of software. You can, if it is malware, avoid lateral movement when you're starting to poke and prod at that piece of that file. You can examine email links and attachments without fear of infecting your own system. You could validate and document indicators of compromise, which can then be used to fortify your defenses. You can learn about your enemy and their tactics. One of my favorite quotes is Sun Tzu, Art of War. Essentially, I'll paraphrase saying that you need to know both the enemy and know yourself. And then you can win your battles. So we want to fortify defenses. We want to figure out how to do a better job protecting our organizations and our computer systems, right? If 75% of computer systems infected with ransomware had endpoint protection and they still got through, we've got a problem here. We can also integrate our findings into security awareness programs. So if there's new campaigns, new ways of phishing, it's not just that same old generic, don't click on phishing emails, users. This way we can have our employees look at real up-to-date things that are coming in and possibly infecting our computer systems. We can demonstrate malicious activity. We can demonstrate intent of malware and how serious this is in our organization. So there's a couple of different ways that you can do sandboxes. You can do them online. There are some pre-built solutions out there like hybrid analysis or any run. There's physical systems you can have as a sandbox. Super messy and difficult to do, but you can do it. There's also virtualization, which is one of my top 2 preferences to use. We can have a VMware with maybe Remnix or some other software like that, or operating system to analyze our malware. Maybe we put it on VirtualBox. There's also the cloud, which is kind of what this talk is about here. So there's some pros and cons to the different solutions, right? With bare metal, if we have an old laptop we grab from the closet and we make that our incident response or malware sandbox, it's going to be difficult. We might get a rootkit that impacts the BIOS or master boot record. We will definitely have challenges restoring or going back to snapshots. There's not a great way to do that. With virtual machines, we gain some of those things, like we can share the file, we can have virtual networks, we can isolate it, unisolate it, take snapshots. It's easy to set up. But some of the cons might be that there are advanced pieces of malware out there that will detect that it's in a sandbox and not detonate or act differently or possibly even escape the virtual sandbox. So there are some cloud instances, and that's what this talk is about, using cloud instances to analyze malware, malicious links, and emails. So some of the pros to that is that you can set it up within minutes. You pay for what you need. You don't need to go buy a Microsoft license or server license. You just spin up an instance for an hour or 2 while you do your work. You can change regions. So maybe you don't want to be in the US anymore. You want to be in Ireland or Germany. You can quickly move that. Whereas if I have a virtual machine on my laptop in front of me here, it's going to be a little bit more challenging to take that to Germany and detonate malware if I need that. We can also create easy images and snapshots similar to using virtual machines, but there are some cons with all these solutions, and the cons to using a cloud solution for your incident response sandbox is that it may violate the terms and services of that cloud platform. So you're going to want to double check that before you actually act on any of the information in this talk. It can also be difficult to completely isolate, right? You need to have internet access to get to the machine that's sitting in an Oregon data center or a Virginia data center. And so doing so, you are giving it some degree of internet access, which may pose as a security risk for you. It may infect other systems. You may be part of a botnet, any one of those things. So you just need to be cognizant of that and make sure you have security controls in place so you are not adding to the bad act of this possible malware or spreading it. Right? And then there's some online tools which can be great, but they've got a time and place for. Some of the cons for these tools like VirusTotal and hybrid analysis is that what you upload is typically now public information, and you might be actually causing a breach by analyzing a file you thought was malware, but it was really the payroll information within your organization, and now you caused that breach. So some of the sandbox concerns, let's go over those. Well, they can be complex to set up and configure, but once you do it, you want to be able to snapshot it or emulate it or clone it or template it so you can use it in the future. Some analysis tools publish binaries to the community. So that's what I was talking about with hybrid analysis, VirusTotal. When you upload a file, they are now publicly available or available to that community. The dynamic and automated tools can also miss indicators. There could be new pieces of malware that they haven't seen before. There could be things that it's not looking for. And so you might want a little more granular way of handling some of these files or emails or whatever you're taking a look at. Advanced malware also has or can have anti-reverse engineering techniques. So that could require internet access in order for the file to detonate or act the way it maliciously would. The anti-reverse engineering tool or technique built into the malware might check that there's a virtual MAC address or it's in the cloud or things like that. It may count the number of files and folders on the user's desktop, right? If you set up a brand new sandbox, you're not going to have your pictures and documents and spreadsheets and stuff like that. So it may look for the number of files and say, wait a second, this sandbox is not looking like a normal desktop of a user that's cluttered. This is probably a sandbox. I'm not going to execute or create that malicious activity like I normally would. Or the anti-reverse engineering technique might just look for certain programs like Wireshark or IDA Pro or whatever they think is a threat to that piece of malware. So what are some of the requirements that I have for my little IR sandbox in the cloud? Well, it has to be easy to set up and tear down. I don't want to have it running forever since cloud is consumption based. I'm paying by the second, I'm paying by the minute, I'm paying by the day. So I want to have something that's very easy to set up and tear down. I want it to be low cost. I don't want to spend hundreds of dollars on this IR sandbox. I want it to be very simple and inexpensive. I want it to be isolated, so I'm not going to infect my organization. I have to be able to give it a virtual network. I have to be able to set ACLs and firewall rules so that it's not infecting everyone else. I have to be able to do static and dynamic analysis. I have to probe and prod at this file, but I also want to be able to run the file and see how it interacts with my system. Were there registry keys created? Were there log files created? Because ultimately, end users are going to double click on the file. They're not going to just poke and prod at it, look at the metadata. So I want to be able to find those indicators of compromise that I can go take back to security engineering and I can fortify my defenses. I want the ability to share with junior members of the team. I want them to see what I'm doing. I want them to see how we can better secure our organization. I want them to see what the latest trends are with malware and how the bad actors are acting, right? Because they probably know us. And as I mentioned, Sun Tzu, Art of War, they need to now know the enemy so that we can win more battles. I also want to minimize response time. If it takes me 3 hours to spin up a incident response box, it's not really a grab and go scenario. I may have a major incident that I want to have my IR sandbox to be able to be deployed within seconds, and then we can get to work. We don't have to sit there and wait. So time is of the essence for me. So here's just a quick highlight of some of the tools that I put on my cloud sandbox. I want something for full packet capture. I deploy that on the endpoint. AWS now has the ability to do full packet capture within a VPC, so you could set that up that way, but Wireshark is just easy for me to use. I also like Process Explorer, Process Monitor, really the Microsoft sysinternals toolkits. I will have that installed or at least readily available. I use Redshot to monitor the registry and any changes a file may have on my file system. Logging with Windows is just garbage by default, so I like to use LogMD to give me a little bit of a guideline of some better logging that I can use, and then I ship those logs off to a SIM. I typically just use Sumo Logic free tier just because it's quick, easy to get set up, a couple of clicks, and now I have all my logs being sent over to a third party. In case the malware wipes my logs, I can go and look at what happened on the log side. I'll use a disassembler like Ollie Debugger, IDA Pro. I use other tools to analyze PE files like TRID, other tools to look at packers or really try and unpack it, so UPX. I want to do memory analysis, so I might use volatility, strings to kind of probe and prod at the different files that I'm looking at, whether that's a binary or a Word file or a PDF file. There's plenty of other PE executable files that are tools that I will use on the sandbox, but you kind of get the gist there. Don't need to go over all of these, but there are plenty of different tools out there for looking at automated analysis. And I like AntiRun, I like Hybrid Analysis, I like VirusTotal, but one thing I always caution people on is you don't want to upload a file that you think is malicious. These tools have a purpose, but I caution you about uploading things to them. If you must use an automated sandbox, maybe a paid solution that's not going to make that publicly available, or you first start with looking at the hash. You calculate the hash of the file, you search that on one of these tools and see if there's any findings or anyone else uploaded the file before you thought of it. So if you're on a Windows system, you can live off the land. You can use PowerShell, the get file hash module, and you can select the algorithm, whether it's MD5, SHA-1, SHA-256, etc. So you just run that against a file as you see on the screenshot there, and you go ahead and you get the hash, which you could then take, search Google, search Twitter, search VirusTotal, Hybrid Analysis, etc., and so forth. If you're on a Linux type system, you can use the SHA-1 or SHA-256 sum or MD5 sum and run that against a file, and you'll get the output, which is going to be that hash, which again, you just copy and paste that and search that in your different search engines. Tons of other tools, not going to have the time to go over each one individually, but there's tools like PE strings, you've got PE scanner, Bordex, hex editors, tons of things out there that can aid you and guide you in some of your analysis. So you could take a look at each one of those if you'd like. A couple more here, more hex editors, more PE tools to take a look at the headers of portable executable files, as well as trying to do file identification and other things that are useful within a sandbox. So some other additional considerations that are not necessarily file or malware analysis tools that I put in my sandbox, but just things to think about. One is Chrome, Firefox. So they are additional browsers, because if you just have Internet Explorer, it looks a little suspicious. And really, who likes to use Internet Explorer, especially in a cloud scenario where they have IE enhanced security turned on, since you're really actually using Server 2016 or Server 2019. So it is challenging to just download files with that thing. So I download Chrome and Firefox to give me some additional functionality and be able to download tools. Other things that I've had problems with on Internet Explorer and my IR Sandboxes, for example, is using the Swift on security configuration file for Sysmon. It causes error in the XML file from time to time when you download Internet Explorer. So again, I just like having those other browsers. I put Silence, Optics, and Protect up there just because there is a company out of Riverside that sells them in single or 5-pack licenses. Not that I am promoting one product over another. You know, CrowdStrike, Carbon Black, SentinelOne, they're all great products for EDR. The point is you want EDR on there. If your organization already subscribes to one, use what you have and put it in detection mode or learning mode. And what that will do is it'll not block anything, but it'll let you know if it detected anything. And so if you have a piece of malware and it's not doing its job detecting, you're going to find that out pretty quickly. So I like to take my tools that I have in production, see in a learning mode or as configuration that we use for organization in real deployment. I want to see how that interacts, what that picks up versus what I pick up, and see if we have any differences there. So again, the only reason I have Silence on the screen there is that you can buy them in 1 or 5 packs from a company out in Riverside. It's the only time I've ever seen EDR where you can buy it in such small licenses. You know, I do have preferences on other EDR tools, but typically the license count's a lot higher. And so if you're doing this as an individual rather than an organization, you can't buy 200 licenses or 250 licenses at a time. I also put Adobe Reader or Acrobat on there if I've got the license, because I want to make sure it looks like a endpoint. I want to make sure that it can open PDF files. If there's an attachment I'm analyzing, I've got to be able to open it like my users would. This is the big one most people forget, is Microsoft Office, right? You probably don't have an extra license laying around, so you don't put that on your typical IR Sandbox. But one, you want to be able to open up files in Word and Excel and possibly see macros and other malicious things that are happening. But you also want it installed, so any anti-evasion techniques the malware might have, it's looking and saying, oh, they paid for a license of Office, it's probably a legitimate system versus a sandbox that's analyzing me. And then multiple files and folders on the user's profile, desktop, documents, downloads. Make this thing seem real. There's tools out there you can make fake files with just padding. Just do something where it doesn't seem like a brand new install of the system, and maybe even keep the sandbox or the cloud sandbox up and running for a month or a couple of days, maybe, whatever you can do, make it seem more realistic, and then snapshot it so that your install time isn't so close to the time you're analyzing the file, right? We just want it more padding. We want as many things as we can in there to make it seem more realistic, like it's a real system that someone uses. And then rename analysis tools to evade detection. I rarely have to do this, but there may be directories like C program files that malware is looking at for those certain malware tools. So possibly install them in a different directory than the default. Okay, so let's talk a little bit about logging. Let's be honest, Windows doesn't provide much logging benefit to us as security professionals by default. For example, the host firewall, you're not logging everything. And actually, when you do start logging stuff, both the private, public, and domain firewall logs are all put into one file that is extremely small that gets rolled over in a matter of hours or days. So there's a lot of changes that should happen in Windows logging, and things we need to turn on, like process creation with command line logging. Why is that not on by default? So those kind of things we need to adjust to make sure that we've got a better view of what's going on this endpoint. You can also do sysmon, which is highly recommended and a great alternative to some of the built-in logging. My preference, though, in addition to sysmon, which I'll then ship off to a SIEM like Sumo Logic or an Elasticstack instance, I like to download the tool called LogMD, and it's a log and malicious discovery tool, but more so when you run the tool, it fails immediately. And you might think, why are you recommending this then? Well, when it fails immediately, it tells you all the things you should change, and you need to start logging for it to actually work properly. So I'll show you a sample of that in a second. And you could either use the Windows logging cheat sheet, which is my preference, or you could use something standard like the CIS benchmarks. So when we run LogMD, what happens is it's a command line tool, so don't try and just double click on it. Run it through the command line with administrative privileges, and then you're going to get an error, it doesn't work, and you're going to get a log file. And when you look at that log file, you're going to see a grid like this, which is phenomenally helpful, even for junior people to see. You're going to go ahead and see your system and what level of logging it has. So you see the S/F. S means it's logging success, and F means it's logging failures. And if you see NA, it's not logging anything on that category. So if we look at, let's say, credential validation on this system, and I've already made changes, so this isn't default, but on this system, it's logging both success and failure login or credential validation attempts. Now, you may want to, as I mentioned, follow some type of standard. My preference is Windows log cheat sheet. Maybe you're using CIS benchmarks, but what you're going to go ahead and do is look at those other columns, and you'll see that, okay, for account logon, other account login events, CIS benchmarks for really everything says you don't need to log success or failure, but Windows logging cheat sheet says, yes, log both success and failure. So you can make that determination on what you adjust within your group policy and then deploy that to the system, rerun LogMD, and see how that's changed and make sure you're logging what you want. So how do you actually start this? What's the next steps for building your little IR cloud sandbox? Well, first, you're going to create an account. It doesn't have to be AWS. I'm just most familiar with that. It could be Azure, GCP, Alibaba. Again, read the terms and conditions to make sure you're not violating anything. And if you are, you're okay with the consequences. You're going to set up that cloud account, and I'm going to use AWS as the example. You're then going to set up an isolated VPC with a public IP address. You're going to create an EC2 instance with at least 4 gigs of RAM. The more, the better. When you create really small instances, one, it might not pass an anti-reverse engineering check from the malware, but 2, it's incredibly painful to run some of these tools in something that's less than 4 gigs of RAM, and modern systems have more than 4 gigs of RAM. You're going to install tools, add logging, fake files, create shortcuts, all that stuff to make it seem more realistic. I like to set a red background on my sandbox to identify that that's my sandbox, and I don't accidentally click or drag things onto my desktop, so it stands out. Once I'm ready, I'll go ahead and create that AMI image of the sandbox so I can use that time and time again as needed quickly. I then deploy the EC2 instance and an isolated VPC as needed. I enable flow logs so I can get transactional data on the VPC if something goes wrong with Wireshark. I then set up ingress and egress ACLs or security groups so that I am only one that's allowed to connect into the system over RDP. And then outbound, I may block or deny a lot of things so I'm not spreading malware. Try to be responsible there, right? And then when I'm running Wireshark or other tools, I try and exclude port 3389, which is RDP. That way it's not super noisy because you are accessing the system with RDP and it will fill up your PCAP files very quickly. So you can exclude 3389 or preferably 3389 from your IP address so you're getting everything except for RDP traffic to and from you. So this is what it looks like when you're done. You've got the red background, all your tools and files and things at the back on your desktop. It looks like a legitimate system to the malware. And that's it. We're done. Thank you for your time. And I want to give a special shout out to all the organizers and volunteers for this conference. The great job that they do spending a lot of their time making this happen, especially when we're all virtual, remote, at home. They're still putting on great events. So thank you. And I encourage everyone who watched this talk, please connect on LinkedIn, Twitter, send me an email message. I love to connect with you and talk. I'll see you next time.